Then we covered equations of motion, right? Derivations of that we covered. We covered speed, velocity, average speed, average velocity. This all we covered. Today's class we are going to do few numericals on based on equations of motion, and then we will see basics of graph. Today's class. So this class is really important because graph will introduce from here itself. Like completely basics will be there. Less maths, more is like about physics. We'll understand graph without using maths. So of course, it is completely dependent upon what, like the observation, what we are observing. From that we will see how like we can draw the graph. So let's see, we will revise, whatever we learned yet, so that we all will revise first. So first, if you will see what we covered, distance, right? Distance is what? Total path length covered by an object is what distance. Displacement, if you will see, what is that shortest distance between initial point and final point is for displacement. After that, we have seen what? Speed, distance by time. Unit is what? Meter per second. Velocity we have seen. There is what we can say speed is what? Speed is time, right? Unit is what? Meter per second, right? Velocity is what? Displacement by time, right? Vector quantity, and that is what? Scalar quantity. Distance is what? Scalar quantity. Unit is same, right? So we can say displacement by time. And then we can say acceleration. Acceleration is what? Final velocity minus of initial velocity with by time, right? After that, we had done three equations. V is equal to what? U plus AT. We had done derivations also. S is equal to what? UT plus half AT square. V square is equal to U square plus 2AS. These three equations of motion also we did. Acceleration unit is what? Meter per second square. We understood like how to find the unit also, that all we had done. So these are the formulas in this chapter we did yet. We did uniform motion, non-uniform motions also, related numericals also we did. We haven't done much more numericals in this. So what I'm going to do here is, today's class I'll do 2-3 numericals, 2-3 problems. It is NCERT based only, and then we'll go for graphs again. Then for 3-4 questions. Like every class I'll give 2-3 numericals, then I'll start the lecture. So that is going to be good for us. And then again I'll write 10 to 15 numericals in the whole chapter. Like 30 numericals I'll write, and then I'll share with you guys. Those you can solve, and then you can ask the doubt wherever you guys will have doubt. So let's see. The first question is what here? A train is starting from rest. Now see how you are supposed to do numerical. That is more important. Starting from what? Rest means what? It says initial velocity is what? 0. Right? A train is starting from rest, so attains a velocity of 72 km per hour. So final velocity is how much here, guys? 72 km per hour, right? 72 km per hour, because we are going to do here is what? Distance, displacement, time we had in meter per second. So let's do with what? Meter per second only, right? So we can say 72. If you want to convert meter per second, kilometer per hour to meter per second, then multiply with what? 5 by 18. 5 by 18 is why? Because 1000 by 60 into 60, right? R it is. So we can say 4 times. So 20 meter per second, right? So final velocity is how much, guys? 20 meter per second. Assuming that the acceleration is uniform motion, find acceleration. So they are asking what? Find acceleration. Time is given how much here? Time, if you will see, 5 minutes. So 5 into what? 60. So 300 seconds, right? So now they're asking acceleration. Easy, no? We can say directly acceleration is what? Final velocity minus initial velocity by time, or v is equal to u plus 80, right? Anything you do. So we'll directly find final velocity is how much? 20, and u is what? 0 by what? 300, right? Acceleration is going to be how much, guys? 20 by 300. So 0 cancel out. So 1 by 15. Okay, let it be 1 by 15 meter per second square. So that we got acceleration. Now we want to find what? The distance traveled by the train for attaining this velocity. Now we have acceleration, we have time, we have initial velocity, we have final velocity. Now they're asking what? Distance. So we can say S is equal to what? Ut plus what? Half AT square. Easy way. So we can say how we use this again. The question arises like how we'll use which formula. So you'll have to check what are the things are there, what they're asking. So almost everything is there apart from what distance. So we can say any formula you can use. Either you can use v square is equal to u square plus 2as, or we can use s is equal to ut plus half ut square. Any formula you want to use, you can use these two formulas. Out of that, any formula you can use. So let's take s is equal to what, ut plus half at square. Why I am using this? Because it will become easy. trigonometry, no, nothing else. What you're supposed to know here, tan theta means what? Perpendicular by base, right? Okay. So we can say if this theta you want to find here also, so this height by this height, this y by x, that also we can say tan theta is equal to what? Y by x, correct? Here also we can say by the same way. Understood till here? Okay. So if you want to find slope and area of any graph, slope and area of any graph, general we are seeing. We are not going to see like specific for speed, velocity and all, that we'll see later. Let's see, we can say what here? X, Y, right? If you'll find the slope of this, right? So we can say what? This distance and this distance is going to be same. So we can say tan theta, guys, x by, sorry, this is what? Okay, anything you can write, any axis you can take what? XY. Fine. Tan theta is what? X by Y. Now area, if you want to cover like this, suppose area you want to cover, then area under this, right? Here we are not going to see curve like this. The problem is here you can't find. Integration will come, calculus will come. So what we are supposed to know, how we'll find the area here? Like this. Area under this. See? Area under this is what? Half base into height. It's easy, right? Or a square, see? Again, base into height, right? Length into breadth. That by that way we can find the area. So you understood how to find slope and how to find what? Area. Area is what? Triangle, square, quadrilateral, anything, trapezium, these things, these types of area will be given. From that you can find. Hope so you understood what is the difference between area and slope and how we will find, right? Okay. So first we understood tan theta is what? Perpendicular by base, and how to find slope and how to find area, that we understood. Okay. Let's see, without learning again the topic name, speed, velocity and all, we are going to see some more things. Four graphs are there. These graphs should know. Let's take, suppose one line is going like this, and one line is going like, coming like this. This is x, y, x is y. Now guys, one thing we can say from here is, what? Suppose if you will consider from here to here, see, if you will see, you are considering 1, this is also 1. If you are considering this is 2, this is 2, this is, if x is increasing, y is also increasing with the same ratio, right? 1, 2, 3, x as well as y, 1, 2, 3, right? If it is increasing like this, so we can say these types of graph is known as what? Uniform graphs. What is that? Uniform graph. Uniform motion, we can say uniformly increasing graph. Let's write here, uniformly increasing graph. Uniformly increasing graph. Now this graph, if you will see here, one, two, three, 1, 2, 3. Now it is 1 and it is 3. Now it is 2 and it is what? 2. Okay. This is 3, then what is 1? It means ultimately it is decreasing, right? 1, 2, 1, 3, 3, 1, right? 1 is increasing, then like it is, another one is decreasing too much, right? That is there. So we can say these types of is what? uniformly decreasing graph. We can say what? Uniformly decreasing graph. Let's see now this graph. Now the problem is, this is 1, this is 2, this is 3, this is 0, this is 1. Now there is a gap. Now it is not uniform. See, we can say this is 1.5 and this is 2. Yes, it is increasing. Both are increasing, then like x is also increasing, y is also increasing, but it is not increasing uniformly. It is non-uniformly increasing graph. Which types of graph is this? Non-uniformly increasing graph. Right now, so anybody can say this is what? Non-uniformly decreasing graph. Okay, so you guys understood? You have a complete idea how many types of graph will be there. Uniformly increasing, uniformly decreasing, non-uniformly increasing, non-uniformly decreasing. You understood what is tan theta, what is slope, what is area. So distance by time. Oh, so slope of distance time graph is what? Distance by time is what? Speed. Very good. We got one thing. It means slope of distance time graph is given by what? Like tan theta, if you'll find in distance time graph, you will get what? The speed. Got it? See again what I am saying you. If distance time graph is given and you are finding slope of that, then what you got here is what? Is speed. The same thing you can, now you come here. Now you write here. Here distance time. The speed is increasing uniformly. Distance time. Speed is uniformly decreasing. Distance time. Speed is uniformly, non-uniformly increasing. Speed time. Speed is non-uniformly decreasing. 4 graphs we learned. Hope so you guys got it. Now put anywhere you can say that whether the speed is increasing or decreasing by the thing which you know. Hope so you got it. Right? Now area under the curve. Area under the graph. Area of speed time graph. Speed time. Guys, we can say area under this, if you want to find, then you'll have to do half base into what? Height, right? Base is how much here? Time. Height is how much here? Speed. Speed into time is what? Distance. So you'll get what? Area under speed time curve will give you what? Speed, distance, right? So now you got area under speed time curve you got, and slope of what? Distance time curve, right? Fine. So you can write one point, slope of distance time curve is what? Speed, right? And area under speed time curve is what? Distance. Now it is square, then anyway anything you take, then this speed into time will come, right? Fine. Now let's see displacement time curve, right? So now you guys can understand easy way. Suppose again the same thing, displacement time, right? So we can say if it is displacement time curve, again you take tan theta, this is, we can say what? Distance, displacement, right? Displacement by time, right? That is going to give you what? Velocity. Array, again the same thing we got. So this slope of displacement time graph will give you what? Velocity. So you can write one point again, slope of displacement time curve is what? Velocity. Got it? So by this way easily you can say slope of displacement time curve will give you what? Velocity. Let's see another thing. What here? Velocity time, area under. So again half base into height, right? Half base is what here? Time into what? Velocity. It is going to give you what? Displacement. See what? It means what? Area under velocity curve, velocity time curve, velocity time curve will give what? Area under velocity time curve will give displacement. Hope so till here you guys got it. Understood, right? How easy it is. Now put here again displacement time, velocity is uniformly increasing, velocity is uniformly decreasing, velocity is non-uniformly increasing, velocity is non-uniformly decreasing. So by that way you can do all the graph and all. We'll see the numericals related to that in next class. Okay, till here you guys revise. We'll see in the next class.